Good morning. Welcome to today's lesson on rates, unit rates, and proportions. Okay, so let's start out with a little vocabulary. What is a rate? Okay, when I say the word rate in math, it has a very specific meaning. Okay, a rate is a ratio. A ratio is just a fancy word for a fraction of two values that are not of the same type. Okay, so we refer to this as sort of an A per B. What do I mean by A per B? I mean, let's give you one that everybody knows, right? Miles per hour, right? Miles is a unit of measure of distance. Hours is a unit of time. Or maybe you're going to the supermarket and it's dollars per, and we use the slash for per pound, right? We're buying, I don't know, buying grapes. We pay by the pound, and we pay a certain dollar amount per pound. Dollars is a unit of money, and pound is a unit of weight. So when we're talking about rates, we're talking about two things that are not related in their type, but they both have we can give them a numeric value, and we're comparing those two numeric values together, and together they form a rate. Okay, so now a unit rate basically says specifically that the second unit, using the term unit, the second value is one. Okay, so dollars per single pound, miles per 1 hour. So sometimes we go to the supermarket and there's a special on, but it's it's $3 for 2 pounds. Okay, that's still a rate. It's not a unit rate. So if we wanted to say, well, what's the unit rate for this? We would have to divide both things by whatever number the second value is, because we need that second value to be 1. So this would be $1.50 for 1 pound. And we abbreviate pound LB. It's from Latin. Don't try to worry about it so much. It just is what it is. So this is a unit. This is a rate. This is a unit rate. And the reason we like unit rates a lot is it's a great way to compare situations. Okay, I said this going to the supermarket. Lots of you are going to go shopping in your lifetime, and you're going to go hundreds and hundreds and hundreds of times. If you figure an average person, especially family, probably goes to the supermarket once a week. Okay, that's 52 times per year. 20 years, you're already there 1,000 times. And one thing that makes shopping more effective, especially if you go to different places to buy different things. If you're one of those people who likes to go to bulk stores like Costco, or you go to Target, or you go to the supermarket, you get your Vons and your Ralphs, you'll find things have very different prices from place to place. Okay, and lots of them have prices like this, where they're something for something that is not a one. But if you really want to compare which is the better deal, where are you getting a good deal on your different products, you want to be able to compare unit rates. That's the simple one. If you know exactly how much it costs for one, then you at this place, and the same, you know how much it costs for one at the second place, then you know which one is the better deal. Also, when you have those options to buy a bigger package, okay, whether you're going to buy a bigger box of cereal, or you're going to buy a bigger container of whatever, if you're buying, is it a better deal? Sometimes it is, sometimes it isn't. That's one thing that always amazes me. Occasionally you'll go into the store and you'll think, oh, it's always a better deal to buy the box of 20 than it is to buy the box of 10. And it's a very simple comparison. If you just double the box of 10, you know what a box of 20 should cost. But every once in a while, the box of 20 is on sale and the box of 10 is not. And it ends up being the better deal. So let's do a couple of let's just look at a couple of things that we think about. Okay, so you take a road trip. Okay, and in this road trip, you drive 400 miles in 8 hours, and you want to know, well, what's my average speed? What was my miles per hour? Well, it's very simple. If you go miles on the top and your hours on the bottom, and then it's a fraction you want to convert into miles per single hour into a unit rate, you go ahead and divide the top and the bottom by 8, and you get that you were going 50 miles per hour. Okay? That's always important to know, okay, how fast you're going, right? So, you know how that'll help you when you know how fast. Hey, I've done this trip before. I usually go about 50 miles an hour. That means it's going to take me 8 hours. Sometimes you use it in reverse. Again, these are things you're going to be doing in your head. You're not even going to realize you're doing them in your head. You're going to be doing them so frequently in your everyday life. You're going to be figuring out how long this trips take. Because what are you going to be doing? You're going to be saying, well, this is how fast I can usually go. So you'll know this number and this number. You'll be trying to figure, you know, what if I go a little faster? What if I encounter traffic? What if I have to go slower? What if I have to detour and pick somebody up? Okay, or drop something off? You know, is this thing really on my way if I have to drive an extra how many minutes, how many miles, and so on. Okay, another use for this would be, let's say you found out, okay, well, I drove 400 miles in 8 hours, and because of the type of trip, maybe I used, and you used, oh, I'm going to make it easy on myself. Let's go 20 gallons gas. Now I want to know, what was my car's fuel efficiency? What was my miles per gallon? You'll see that. You watch a commercial. If you watch one football game this season, you'll see probably 20 car commercials, and oftentimes they want to tell you how fuel efficient they are, what a great miles per gallon they get, how much that'll save you because you won't have to buy gas as frequently. All those sort of things become part of your everyday existence that you just acknowledge. Hey, I like this car because it's got a way better miles per gallon than that one. Sometimes you'll hear it referred to just as simply MPG, miles per gallon. So you would, again, same situation, 400 miles to 20 gallons, divide them both by the 20, and you're finding you're getting 20 miles per gallon, MPG. By the way, that's not very good. That's actually about what a truck gets. If you get a really fuel efficient truck, you might get it all the way up as high as 20. I think maybe to 25. You know, like 23 is really good, but 20 is like what most trucks get because you're using them to haul stuff, which means it's not, you know, they're not terribly fuel efficient. If you start looking into, you know, just for your own amusement, figure out what the fuel efficiency of a motor home is. How many miles per gallon do you get on like a big RV? How much does like a big SUV or a Hummer get? How much does a car get? How much do those little electric cars get? How much do those little smart cars get? Look at those total. You'll see huge variety in how many miles per gallon those cars, those different vehicles get based on how fuel efficient they are. Sometimes you hear that as a term when you're watching. You're seeing, oh, this car's got really good fuel efficiency. That's because it has a really good miles per gallon. And again, it's so easy to compare to another car. Okay, if they all threw out, you know, each car said, hey, our car gets 422 miles to 36 gallons, and the next car over said we get 283 miles to 12 gallons. And you'd be sitting there going, well, which one's more efficient? And then you'd have to figure out their unit rates. So they like to present them to you in the form of a unit rate. Okay. In fact, like I said, your speedometer is just a constant unit rate of this is your number of miles per gallon, or miles per hour, excuse me. Meaning if you were to be driving at this same speed for the next hour, you would go that many miles. That's when you look at the speedometer and it says you're going 50 miles per gallon, 50 miles per hour, you're going, if you drove for the whole hour, you'd go 50 miles. If you drove for half an hour, you'd go for 25 miles, and so on. Okay? So that's rate and unit rate. And you almost always are going to want to convert things to unit rates because it's for comparison purposes. You'll see this also in your science class. You'll probably see this formula if you haven't already. Distance equals rate times time. That's what we've been saying about miles per hour, which is however long you drive times however long you drive gets you your distance. If you're going 50 miles an hour and you drive an hour, that's 50. If you drive 50 miles an hour and you drive half an hour, that's 25. So distance equals rate times time. So it's another application of understanding what the word rate means. It's when you're, it could be all kinds of things, but we use rate in this time very specifically to mean speed. So speed is a rate, and it's almost always delivered to us as a unit rate, okay? Until you get into something like, start talking about Mach, like really, really fast speeds. Mach 1, Mach 2, the sound barrier. What are those rates? Okay? All right. So let's do a little, real world application here of just for my own amusement, okay? Again, this is just something you may find yourself doing when you're living on your own. Maybe you're living in the dorms, maybe you're living in your own apartment, maybe you got your job and you're starting to wonder, which is a better deal. So you can get a box of cereal for $2.89 that has, I can get that number, has 20 ounces. And by the way, ounces is abbreviated OZ. It's another one of those welcome to the wonderful world of we take words from Latin. And a larger box costs $3.49 for so this one's 20 ounces, my bad. Sorry, this one was only 16 ounces. I was, again, trying to read. Hope that wasn't too distracting. So a box of cereal for $2.89 that has 16 ounces, and a larger box costs $3.49 for 20 ounces. And again, this is not earth-shattering. This is not going to change your entire existence if you grab the less efficient box. But this is the kind of stuff that if you're making these kinds of informed decisions all the time through your life, you'll have that little bit extra money always. That's a wonderful feeling, let me tell you. Okay, I'm not saying spend your whole life bargain hunting. I'm saying that if every time you make a decision, you make a decision that is slightly more advantageous to you, down the line you'll have found you have more money, you have more time, you have more of whatever it is that you are saving by making that informed decision. Now, how do I decide which one's the better deal? I turn them both into unit rates. I say, well, small box is $2.89 for 20, sorry, I did it again, for 16 ounces. And the second box is $3.49 for 20 ounces. And if I just turn the two into unit rates, it'll be very easy for me to compare them. And then I'll know exactly which box I should be buying. And then I'm flexible, right? The next time I go, if there's a sale, I'll know which one. I'll be able to check it because I'll already know how to do this process. As it turns out, this one is about 18.1 cents per ounce. And this one is about 17.5 cents per ounce. Now, obviously, this is not going to make you a millionaire by saving, 6 cents an ounce on your breakfast cereal. But it is the kind of thing that when you realize, hey, I'm buying 20 ounces. If I save 6 cents every time, I'm going to be saving money every time, every time, every time. And this isn't even 6 cents. This is 0.6 of a cent. Okay? But it's that idea that if you're saving money every time you make your purchase and you're always making the advantageous purchase to you, then at the end of a year, a month, or whatever, you're going to have that little bit extra money that you can then use for whatever you want. Okay, and then when you start applying this to slightly larger purchases, like maybe a big TV or a stereo system or something, or a car, then you'll really start to see, hey, you know what, if you save, it's not 6 cents anymore, maybe it's $600 on the car because I buy it here versus there. That might even have to do with the tax rate. Okay, once you start to make those kinds of decisions, you'll see it applies to bigger things and it becomes a bigger deal. Okay, right now, talking about boxes of breakfast cereal. But eventually, we're going to be talking about much bigger things like cars, houses, and the like. All right, so that's finding a rate and finding a unit rate. Okay, now let us discuss the other part of today's lesson, and that is a not an amateur, a proportion. And it's not like that. It's a proportion. And a proportion is two ratios equal to each other. Two ratios, again, just a fancy word for fraction. Sorry, it is two ratios equal to one another. Okay, two ratios equal to one another. Let's do one with just two ratios. So if I said 1/2 and I said, what's another fraction that's equal to 1/2? You could say, well, 2/4. That's a proportion now. Okay, we've got two fractions equal to one another. It's a proportion. Now, assuming it's correct, which it is, there's a way to check this. Now, how can I be sure that this is a proportion and it's correct? Is if I cross multiply, which is to say I multiply diagonally from denominator up to numerator. When I do that, they should give me the same result. So 4 times 1 is 4, 2 times 2 is 4. That's a proportion. It is absolutely true. It is correct. I could check any ratio, any set of ratios that you gave me. This goes back to maybe the 3rd grade or the 4th grade when you were asked, which is a bigger fraction? Greater than, less than. Is it equal? Is it greater than? Take the cross products, you'll know the answer every time. It would have saved you a lot of time of, well, maybe I had to turn it into a decimal and compare those. I don't need to. Cross multiply. Whichever side has the bigger answer, that's the bigger fraction. If they're both the same, it's equal. Okay? Now, how are we going to use this? Okay? We're going to be getting proportions where one of these values is a variable. Okay? So if I were to have done this again and said, and I want to know this value, now I have to figure that out. Now how do we figure it out? Same way I just checked the last one. We cross multiply. Some of you, I've heard this before, and when we do this, we create like a little butterfly. I always love that term, kind of funny. So 4 times x is 4x, 2 times 2 is 4. And now remember, if you remember back to the last lesson, I said we're going to divide by the number next to the variable. We're going to do it 1,000 times. Here's one of those times. And sure, we knew it was a half. We knew it was a 1 already. But that's how we solve these kinds of proportions. Now, this is one that becomes super, super important if you become a parent. I know you're going, what? How is proportions really that important to parenting? Here's the why. When you give medicine to a child, you'll find that it'll say on the side of the package, this is for children such and such an age, 3 to 10. Okay, but I assure you, the medicine they're asking you to give to a child has absolutely nothing to do with age. It has everything to do with size. Okay, how big is the child? Okay, because it's how much space, if you're giving them, a painkiller, how much area does it have to go through before it gets to the location, because it gets dispersed. It doesn't just go. It's not like you take an aspirin and all the pain medication goes to your shoulder. It goes to your shoulder. It goes to your other shoulder. It goes to your head. It goes everywhere. And if you're a big guy, you need a little bit more medicine. Okay, I'm watching football all the time, and I can assure you those guys take more medicine than I do because they are much bigger than I am. Unfortunately, not much bigger anymore. But hey, so when they're looking to, well, how much should they get? It's not a function of their age. It's not like, well, this guy's 20, he should get this much, and this guy's 40, he should get that much. It's this guy weighs 260 pounds, and this guy weighs 180 pounds. They don't need the same amount because they don't have the same amount of space that they have to fill up with that. Okay, and that is, it becomes really important when you start dealing with really tiny children, little babies. Okay, my sister works she works in a gynecological OBGYN, which is babies and women. It's called birth. It's all about birth, basically, those two categories together. And she's called me a few times going, I just want to make sure my math is right. And you're the guy I check. I don't use a calculator because I'm thinking I just want to make sure I'm setting it up right. Because she knows that, if this baby it doesn't matter how old the baby is, it matters how big the baby is. If the baby's 5 minutes old, but a 9-pound child, that's very different than a baby that maybe was born prematurely. So started out as maybe only 5 pounds, and this might be a 3-month-old, but now it's only up to 7. It's not the same amount. Even though one baby is older than the other, the one baby is larger. That's what really determines which one should get how much more medicine, or how, and how does that relate to a normal dose? What we call a normal dose for an adult, maybe. Or maybe it's something you normally give to a 6-month-old. It's normally for babies, children that are 2. Okay, well, a 2-year-old is bigger than a 6-month-old, but maybe this is that weird time when you really have to give them something. And you need to know what's the right amount, and the way you figure that out is you use a proportion. Okay, so if the child, if you give 20 milligrams to a 2-year-old, how many milligrams would you give to, well, again, I don't care how old you are. I care, hey, that 2-year-old, he weighs 25 pounds. How about if I only had, let's make my math easy. Let's make this kid 24 pounds. We'll make this an 8-pound kid. How much would I give then? And you have to figure this out. You cross multiply. 8 times 20, that's 160. 24 times, well, we're going to call that x. So 24. And we're going to divide by 24. And we're going to get, about 6.66 repeating milligrams. So we're going to give far less. Okay? Because if we gave them the full dose, even if he was that same age as that first child, I said he was 2 years old, you might be giving way too much medicine to a small child. You don't want to do that. And this is something you will use to make that determination. It's called a proportion. Okay? We also refer to it sometimes when we talk about models and such as scale factor. We'll talk more about that later on when we get to that section again. But for proportions, this is how we're going to be solving. So let me run through one more example, and with narration here, so I can walk us through this. So we can say x over, let's make my life easy, 12 is equal to, let's say 15 over 60. Okay? And this is how I'm going to want your work to look. And I want to make this clear because I'm still seeing people that are taking liberties with how they show their work. You're not to take liberties. You're got to show it the way I show it. Okay? And it's not because I'm being a pain. It's not because I just want it a certain way. It's because I know if you keep doing it the right way every time, when we get to more complicated things, it won't get more complicated. So again, we're going to cross multiply. So 60 times x is equal to 12 times 15, which is 180. And then we divide by the number next to the variable, and we get our answer. So cross multiply, and then divide by the number next to the variable. Two steps. Easy peasy, very quick. You're going to find, you do it, you just show me, give me arrows, or if you want to go with the butterfly, something that indicates to me that you're cross multiplying, and then show me that you're dividing. Again, I want to see the steps. Steps matter, answers not as much. All right, I will see you in class or in the office hours.